wanted to talk about symmetry today. So I would like you to look at this parabola over here, and hopefully you know a parabola has this thing called a vertex. In this case it's at 3, 1. And since I wrote the function in vertex form or standard form, you can see the 3 and the 1. That's where the vertex is. So in this form, notice the x only shows up once, not twice, and the squared is here. So this is written as a transformation of x squared. This is just x squared moved to the right 3, up 1, and stretched vertically by a factor of 2. So you can see over here 3. All right, this parabola has a shape that's symmetric, meaning if the right side of it looks just like the left side. Okay, so it's what we would call it has a symmetry, and x equals 3, this line, this is called its axis of symmetry, because if you folded it over the dotted line, it would match. Okay, so that's a type of symmetry. Now when we talk about other things like let's see, a symmetric function or an anti-symmetric function, or even or odd, okay, we're leaving out part of the sentence. We really mean symmetry about the y-axis or anti-symmetry about the y-axis. We leave these out because it's just a lot of words to say. So just like this guy had symmetry about its axis of symmetry, right? If we want to talk about something that's symmetric about the y-axis, that means its axis of symmetry is the y-axis. So let's get rid of u. Let's look at another function here, like this guy. This is the simplest parabola there is, x squared. This guy is symmetric about the y-axis. Let me put a little x equals 0 in there, and we'll give you a little dotted line too. Well, let's try it with this thing. I'll make it like orange or something. There we go. So there, that's the y-axis, and so this parabola is symmetric about the y-axis, so we would call it a symmetric function, x squared. The right side looks identical to the left side. Okay? Now, again, this is symmetric about the y-axis. We would call it an even function. All the x's have an even exponent. Now this guy, again, compare it to this one. This guy has a symmetry, but it's not what we would call an even function. You see, if I folded this red one over the y-axis, we would end up with that. That blue is not the same as the red. So although it has symmetry, it's not symmetric about the y-axis, so it's not an even function. Okay, that's an even function. That's symmetry about the y-axis. Now, what is this anti-symmetry? Well, that just means instead of the left side being the same as the right side, it means that the left side is the negative of the right side. So an example of that would be x cubed. Look at this guy. The left side is exactly the negative of the right side. So for any y value over here, or for any x, whatever y value you get, if you plug in the negative of that, you get the negative y value. Okay, so this is called anti-symmetry. It's also called odd. And it happens whenever all of the terms, every term, has x to a negative power. And you'll be able to see that soon. So if I took this function and I flipped it over the y-axis and then I flipped that over the x-axis, I would end up with the same thing. So check it out. This is what I get if I flip it over the y-axis. Hey, stop it. Okay? Now if I take that and flip it over the x-axis, I get this. So the double flip here, flip over y and then flip over x, it looks identical to the original, right? So that's another way of saying the left side. The left side is an upside down or right side, okay? So what we're saying is this is the same as just regular old j of x. And we'll talk about that more soon. Okay, so that's anti-symmetry. It's also called symmetry about the origin. Here's the origin. If I rotated this graph 180 degrees around the origin, it would look identical to itself. So that's why it's called symmetry about the origin, or anti-symmetry about the y-axis. The anti, because the left side is the negative of the right side. That's why it's anti-symmetry. And also called odd, because it happens whenever every single term has x to an odd power. So let's look at some definitions and stuff here. So what I want y'all to understand, symmetry about the y-axis, aka even. Okay? I want you to be able to look at a function, look at its graph, and tell me if it's even. Or look at the function written out and be able to tell me if it's even. And I want you to prove to me that it is even by showing this, showing that the left side is the same as the right side. And this will happen if every term in the function has a variable with an even exponent. I say be careful. Okay, check out, here's an example. F of x equals x squared plus 1. Okay, if I replaced, well, I guess I could put this over here. Let's make this pretty. We could put you up there. If I replaced x with negative x, and here is a little technical thing y'all seem to have problems with. Everywhere there's an x, replace it with negative x. Here's an x, I'm going to replace it with negative x. And there's no x's here. So you need the parentheses because the x is getting squared. We're replacing the x with negative x, so the negative needs to be squared too. Now, what does it mean to be squared? It means you're multiplying it times itself. I should write that a little more clearly. Okay? You see that? You have two minus signs. Two minus signs. A minus times a minus is a plus. So the minus signs went away. Those two minuses cancel out. Well, this is the same as our original function. Right? So the left side is equal to the right side. So flipping the graph over the y-axis leaves the graph unchanged. And I can just look at this and immediately tell if I replaced all the x's with a negative x, all the minus signs would disappear, because here's the only place I would put minus signs in, and that would make them disappear. Okay? And every single term here, again, the things you add are called terms. That's a term, this is a term. They all have x's to even exponents. Now you might be like, hey, what about this one? It doesn't have x's. Sure it does. You can always put x to the 0. Remember, anything to the 0 power is just 1. So if you want to write it out, all the terms have x's to even powers. That's why it's called an even function for slang. Okay? So every term, every single one, has a variable with an even exponent. And again, just look at it. If I replaced x with negative x in every term, would all the minuses go away? If so, then this will be the same as that. And the graph will be symmetric. Let's see, come here. The right side, here's a, oh, why is that blue one still there? Go away, there. See, give me an x, say x is 2, the y value is 4. If you give me negative 2, the y value is still 4. Okay? Look, I could change it up. Let's do a, I'm going to do x to the 4th minus x squared. All the x's have even powers, so it is symmetric. Now, adding is just going to move this up or down. If I put plus 3, it's the same graph, just moved up 3. It's still symmetric. And this is really x to the 0 if you want to put it there, because that's just equal to 1. Notice how all the terms have even exponents, and I could put minus signs in the front. It doesn't matter. It's still even. Still even, right? I put pluses. I could put fractions. I could put whatever I want for the coefficients. Okay? Still even. Okay? And if I replaced x with negative x, it's the exact same graph. Because everywhere, if I replaced x with a negative x, 4 minuses cancel out, 2 minuses cancel out, 0 minuses, there are no minuses. Okay? So that's an even function. It all has to do with about the y-axis. Okay? So let's look at anti-symmetry about the y-axis, aka symmetry about the origin, or odd. So is a function anti-symmetric or not? So if you have something like, I don't know, just pick a random function, x squared plus x minus 1 or something. Make up a function. It doesn't have to be a quadratic. It could be any function at all. Okay? It's just easy to see if we have a polynomial. So is this anti-symmetric? Well, what does that mean again? It means odd. Let's go back to our little example. Here's our simplest one. It means the left side is the negative of the right side. So that means if I took the graph, I like to think of it like this. For me, I think of it this way. If I replaced with x with a negative x, is that the same as the negative of the function? Or is the left side the same as an upside down right side? And the book presents it differently. This is the same question as this. So there's a minus. If you multiply both sides by a minus 1, you'll get a minus over here and would cancel that one out. So this question is the same as this. Is the left side the same as upside down right side? That's the same thing as saying if I take the function and I flip it over the y-axis and then take that and flip it over the x-axis, nothing has changed. So these are equivalent questions. I like to do it this way. The book likes to do it that way, because I can look at a function. So what is this saying? It means if I replaced x with a negative, would every single term give me an extra minus sign? This is not an odd, let's do one that's naturally an odd function. So I can tell you right off the bat, like x cubed minus, oops, come here, there we go, minus x. I can tell you this is odd because this is really x to the first. Every single term has an odd exponent, and if I replaced x's with negative x, like this, what would happen? Well, 3 minus signs. Here's another minus sign. Each term is going to have an extra minus sign compared to the original. Okay? So 3 minus signs, 2 of them cancel, and I'm left with 1. Here, I'm going to go ahead and leave it like that. Minus minus. Might look silly, but it's for a reason. So what happened is each of the terms got an extra minus sign. There it is. That means I can factor out the minus. So here I got a minus, right? Minus x cubed minus minus x. Well, this is a minus sign in front of the original function. Okay, so I like to do it like that because, again, every single term, this term, that term, if I replaced x with a negative x, I get a extra minus here, and that extra minus, I could just pull it out front of the whole function. So we can see that the left side of the function is an upside down right side. Okay. Now, the way they like to do it in the book, though, is they want you to find this first, and then they want you to find this next, and show that this is the same as the original. Well, we don't need to redo work. Oops, sorry, I miswrote this guy. There we go. We already found this. Okay. Okay, we could simplify that. This is negative x cubed plus x. Right? This is f of negative x. So if you want to find the negative of this guy, well, there's our minus. This has multiple terms, so make sure you put parentheses. And what is this? We just found out what it was. It's this guy. Boop, ba-doop, boop, boop. So this is f of negative x. So all you're doing is hitting everything here with an extra minus. Okay, negative times negative is positive, and then a negative x. So look, this is the same as the original function. So there's two different ways of doing it. All right, this says if I take the function, flip it over the y-axis, and take that thing and flip it over the x-axis, I end up with the original function. Okay, or if I took all the x's, replace them with negative x, all right, when I do that, every single term gets an extra minus sign. Boop, boop. I can pull that minus out front of the original function, and then this minus will cancel that one. So what's happening here is, since we saw that this is exactly the same as this, right? Every term gave us an extra minus sign, and we just pulled it out front, right? Well, because of that, we saw that negative f of negative x is, there's a minus sign, okay? And we just saw that this is the same as the negative f of x. So those minus signs cancel. So the double flip leaves the graph unchanged. So there's the concept, which is great, the visual on the graph. Then there's the analytic part, being able to prove it, which this looks super complicated, but it's really not. Let's look at some examples here. Here's an example. F of x equals x squared minus x plus 1. Is it even or odd? I can tell you right now it's neither. Why? Because if I replaced x with a negative x, here the minuses would go away, but here I would get an extra minus sign, because this is x to the first. There's really an x to the 0. Look, I have exponents that are both even and odd. So every function is a combination of even and odd. If it has both, then it's neither. Let's look at the graph. X squared minus x plus 1. Let's put that in here. We'll put it right here. Here we go. X squared minus x plus 1. All right. Boop. There. So look at that graph. It's a parabola. Sure, it has an axis of symmetry. If I folded it over x equals 0.5, it would be symmetric around. So it's a symmetric about the line 0.5. Okay? But that doesn't make it an even function. It doesn't make it symmetric about the y-axis. You see? Here is the y-axis. If I took this guy and I replaced x with negative x, I don't get the original function back. So it's not even. And if I did the double flip, oops, okay, it's not odd, right? So the left side, I don't like this. Let's see, what do I want? Meh, yeah, let's look at this. So this is not the original function, so it's not even. And this is not the original function, so it's not odd, right? The left side is not an upside down right side, so it's neither, okay? And again, you could just look at it and tell, because if you replaced x's with negative x, you're not going to get the same function back, because this guy is going to give you an extra minus sign, okay? And it's not odd because it's only odd if every term gives you an extra minus sign. This one wouldn't give us an extra minus, and this one wouldn't if we replaced x with negative x. So you can just look at it and tell that it's a neither. So let's pick a different function here. Let's just do, oh, well, let's prove it just by saying it's true. So here's how I would prove it. So if I replace x with negative x, replace the x with a negative x, replace the x with a negative x. Okay, what happens? These minuses, since there's two of them, cancel out. Here's a minus and a minus. We can write that as plus. All right. Is this the same as that? No. This one changed. The rest of it's the same, but that changed. So this is not the original function. So therefore, it's not even or symmetric about the y-axis. Now the way I like to do it is I want to know, is this the same as negative f of x? Well, let's see. If I pulled a minus sign out of everything, oop, we need another minus. Okay, so two minuses make a plus. Two minuses make a plus. Two minuses make a plus. All right, so this is a minus sign. Is this f of x? No, it's different. This is a plus, minus, plus. These are all minuses, right? So I know right there it's not odd. But again, the way the book wants you to do it is say, well, okay, now that we know what this is, what would this be equal to? Well, we have a minus sign, and this we already calculated to be that. So replace this with what we already found, x squared plus x plus 1. And we get minus x squared minus x minus 1. So is this equal to the original function? No, it's not. This is not f of x. Right? It's different. Plus minus plus, minus minus minus. So therefore it's not odd. And again, how do we look at it and tell? If I replaced x with negative x, here it wouldn't make a difference. Here we would get an extra minus. So to be even, all the minus signs would have to go away. Now, what about odd? Okay, if I replace x with negative x, to be odd, every term would have to give me an extra minus sign, so that, where'd it go? So that when I pulled this out front, this is not negative f of x. You see, if I replace x with negative x, if every term gave me a minus that I could pull out front, then I would know that it's odd, but it's not. So this is not odd. Okay? That's what I forgot to write. The minus. This isn't f of x. So this is not that. Replacing x with negative x does not give us a minus sign in every term that we can pull out front. So it's not odd. And again, saying this is equal to that, multiplying both sides by a minus is the same thing as saying, asking, is this equal to the original function? So does the flip over the x-axis give us the negative of the right side? Or does the double flip leave the function unchanged? Let's look at another example. Let's say g of x equals, I don't know, 4. X to the fourth minus x squared plus 1. Is that even or odd? I can tell you right now it's even. I can tell you right now that this is the same as this. Why? Because everywhere I replace an x with a negative x, here all the minus signs would cancel out, here all the minus signs would cancel out, and here there wouldn't be any minus signs. All right? So it is even. To prove this, all right, well, okay, fine. Replace x with negative x, boop. Replace x with negative x, oops. There. So I got a 4. 4 minus signs, they all cancel out. 2 minus signs and another minus sign. All right, well, these two cancel each other out, and I still have this one, and then the plus 1. And this is exactly that. Okay, so it's even. And again, if you want, look, even, even, even. All the x's have even exponents, right? So it's even, it can't be odd, okay? The only way it would be odd is if all the exponents are odd. Let's graph this thing. 4x to the fourth minus x squared plus 1. All right. 4x to the fourth. I forgot the other part. Minus x squared plus 1. Minus x squared plus 1. There you go. Look, if you fold it over the y-axis, it matches. See? Here's the graph of it over the y-axis. It matches. It's exactly the same. Yay! All right, let's look at an odd one real quick. So h of x equals minus x to the fifth plus 2x cubed plus x. Yeah. So I can tell you right now this dude is odd, because if I replace x with negative x, I'm going to get exactly the negative of the original function. The left side will be the upside down right side. How do I know? Because everywhere there's an x, well, I shouldn't say that, I should say every single term has an x to an odd exponent. So I replace x with a minus x, all the minuses cancel out but 1. Here they'll all cancel out but 1. Here you're going to have 1. Every term will give you an extra minus sign, and we can factor it and put it out front. Here, I'll show you. If we keep the minus, replace x with negative x, replace x with negative x, and then replace x with negative x. Okay. We have 5 minus signs, 6 minus signs. They all cancel out because it's 6 of them. Okay. And over here we have 3 minus signs. 2 cancel out. We're left with 1. Here we got a minus. Okay. Factor a minus sign out of everything. I know this one doesn't have one, so we'd need to have another one here. Negative, negative makes plus. This one, we factor it out. And then this one's minus. We need a plus, right? Negative, negative makes plus. A minus, minus, and minus. So this is a minus sign. And this is the original function. So it is odd. Oh, I should call it H. It's H. The left side is an upside down right side. Again, the book doesn't think you can handle that. They think you can't factor a minus sign out and then see if this is your original function or not. So they make you do this. What is this guy? So instead of asking, is this the negative of that, they want to ask, is the double negative the same as the function? Well, yes, it is, because this is exactly the negative of the function, right? All of the terms, if we did put minus x in here, every single term gave us an extra minus sign. And then if we hit them all with another minus sign, the minuses cancel and we got the original function. All right, so what is this guy? Well, we have a minus, and we just showed this is the same as negative h of x. So we replace this with negative h of x. The two minuses cancel. Yay! Or, if we want to be painful about it, negative h of negative x. Let's reuse this. Okay, there's our minus. This guy we did right here was exactly this. So since we already did that work, let's steal that. Make sure you put your parentheses because we are subtracting all of this, and this guy has multiple terms. So this minus needs to hit all the terms. Negative x to the fifth, minus minus makes a plus, minus minus makes a plus. This is the original function. Exactly. Minus plus plus. Minus plus plus. So this is the original function. All of these are saying it's odd or anti-symmetric. Now if you wanted to redo all your work, we can do that. Here's the terrible way to do it, but hey. All right, here's our original function. I want negative h of negative x. Let's just do it all at once. All right, I got a minus sign. Boop. This has many terms, so make sure you have your parentheses. Now what is this guy? This is this, where you replace all the x's with negative x. So I got a minus sign. Replace x with negative x. I got a plus 2. Replace x with negative x. I got a plus sign. Replace x with negative x. Okay, now there's the minus. Here is this guy. We just replaced x with negative x, so what do we get? A minus minus makes a plus. Okay, so those cancel. And here we have 5 more minuses. So how many minuses total? 5, 6, 7. So 6 of them will cancel out. We'll be left with 1. Okay, now what about over here? We have 3 minuses, 4 minuses. They all cancel out. Great. What about here? We have 1 minus, 2 minuses. They cancel out. Look at this. This is the original function. So therefore it is odd. All right. Flip over the y-axis and then take that and flip it over the x-axis, and the graph looks exactly the same. So that's the long way to do it. Again, the way I like to do it is just like this. The left side, replace x with negative x, replace x with negative x, replace x with negative x. We have 6 minus signs, so they all cancel out. 3 minus signs, we get a minus. Here's a minus, and I want to compare this. Is this the upside down? Is the left side the upside down right side? So here's the upside down. So factor out a minus. Right? Minus minus makes a plus. Minus, yeah. Yeah, okay. This is not a negative. This is not the original function. I mean, sorry, it is the original function because this is odd. We have a minus sign, and this guy is exactly our original function. This is original function, right? So since, again, the left side is the upside down right side, it's odd. And you can also say, well, since we proved this, multiplying both sides by a minus, multiply this side by a minus, oops, Multiply this by a minus, the minuses cancel out. This is just simply another way of saying that it's odd. Let's graph it. X to the 5th minus 2x cubed minus 1. All right, x to the 5th, and I already forgot. Where are you? Where's my function? Oh, negative x to the 5th plus 2x cubed plus x. Negative x to the 5th plus 2x cubed plus x. Is that it? Minus, plus, plus? Yeah. All right. Let's hide this thing. Go away, go away. All right. So the left side is an upside down right side. Boom. Look. If I took this graph and I flipped over the y-axis, I would get that. And then if I took that and flipped it over the x-axis, oops, I get this, the original function. All right, so h of negative x. I can just look at this and see if I replaced x with negative x, every term would give me an extra minus sign that I could factor out and put in front of the function. So this is the same as this guy. Watch this. Here. Since this, oh, let's hide it. There we go. Since this is the same as, oops, this, that means this guy is the same as, well, that. All right, it's an odd. So one last thing about odd functions. I want y'all to be careful here. So here, where's x cubed? Here's the simplest odd function of them all. The left side is an upside down right side. Sure. If I move this to, say, oh man, the left, minus 1, boop. This is no longer an anti-symmetric function. Sure, it has a symmetry of an axis of anti-symmetry, but the left side, meaning the side on the left half to the left of the y-axis, this is not the negative of the right. Check it out. If I did the double flip, that's not the original function, is it? Just because you see this cubed here, that's not going to tell you anything. You'd have to multiply this out and put it into general form. All right? This cube means you have to multiply all this stuff out, right? So check this out. If I did squared, this is not an even function. The left side is not the same as the right side. You'd have to multiply this out. This is the same as x squared minus 2x plus 1, right? If you multiplied that out, you would get this. Okay? So you multiplied that out, you can see you have x's that are even and x's with odd exponents. Okay? That's why it has both, even and odd. So it's a neither. Okay? Let's go back to x cubed. Definitely odd. The left side is the negative of the right side. If I move this up one, this is not odd. The left side is not the negative of the right side because it's not going through the origin here. Look, here is, if we do the double flip, if I flip that over the left and then the right, that's what we would get. Or I could say, this is not the negative of the original one. Okay? That moving it up one messed everything up. Because remember, 1 is really, there's an x to the 0 power there. So you have odd exponents and even exponents. Okay? So this is not anti-symmetric. If I flip this over the y-axis and then over the x-axis, it would not match. Let's see how I can say that. The left side is not the negative of the right side. Look, if I plugged in, what is this, 1 here? If I plug in 1, I get, boop. well, 1 cubed is 1 plus 1 is 2. So if I plug in 1, I get 2. But if I plug in negative 1, I don't get negative 2. I get 0. Right? So again, to be odd, when I plug the negative version, the negative x in, I should get the negative of the other side. So when I plug in 1, I get 2. But I plug in negative 1, I don't get negative 2, I get 0. Because it's all been shifted up. So this is not the same as the original function. So it's not anti-symmetric. Okay? So that's not anti-symmetric. Kind of for the same reason that, oops, this is not symmetric, right? The right side is not the same as the left side because we're talking about the y-axis here. Okay, that is not an even function. Okay, it does have symmetry, but its axis of symmetry is at x equals 1, not x equals 0. So anyhow, I hope this clears up things for you. The best thing you can do is to learn is practice. The way I suggest you practice is come to Desmos, pick any function, just make one up. It doesn't have to be a polynomial, but whatever. There we go. Just pick a function, any function. Look at the graph. Ask, is it symmetric or is it anti-symmetric, right? Or is it neither? Well, if you type it in like this, actually type in f of x, right? Then you can just type in this guy. So is this the same as the original function? No, it's not. So it's not even. Okay? And then you'd be like, okay, well, what about odd? Well, is this the same as the original function? No, it's not. So it's not odd. Right? And then prove that. Actually do the math like this to prove it. Okay? Type in something like this and be like, oh, well, let's see, I'm going to do x to the 4th. Just pick any kind of function you want, you know, -3. Okay? Now, is that symmetric? You're like, yeah, it looks symmetric. And then check. Yes, it's symmetric. That graph is the same as that one. It's even. Yay! Now that you've done that, prove it by actually doing the math. Right? Go in and replace x with negative x. Even though it should be obvious at this point, get good at writing it out. Okay? Obviously, everywhere I replace x with negative x, all the minus signs would go away. So this guy is going to be the same as that. You can just look at it and tell. But you need to be able to write that out now. Right? And it doesn't have to be polynomials. We could do something like, I don't know, let's do like square root of x plus 3. All right, there we go. Is that symmetric? No, there's only a graph on one side. It's neither. All right, it's going to do weird stuff. If I did like, I don't know, you take this guy and boop, 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 boop. Let's do something weird here. Now cube that, all right? Oh, I don't even know where it went. Oh, that's kind of an ugly one. That's too weird. Let's do something. X minus 2. Oop, no. Oh, man. Come here. Oh, well, fine. Here we go. Boop. Nope. Come here. I'm going to do x plus 3 to the 4th power. So what does that do? All right. Is this an even function? No. If I folded it over the y-axis, I would not get the same thing. It's not even. This f of negative x, what is that? That's not the original function. Not even. Even though you see that 4 there, remember, this 4 means x plus 3 times x plus 3 times x plus 3. If you multiplied it all out, right, some terms would have even x exponents on x, some would have odd. Okay? So is it an odd function? No. That's not the original function either. And then you can prove it. It's easier to do these when things are multiplied out. It's hard to do it like that. Let's look at an example. Okay? Check this out. Now, here is a 2, x minus 1 squared plus 3. All right, I can immediately tell you this is neither. Why? Because I know that this is a parabola and its vertex is not on the y-axis. I could tell you this is a transformation of x squared. It's a parabola that opens upward, the vertex at 1, 3, over 1, 1, 2, 3, something like that. It has an axis of symmetry at x equals 1. The axis of symmetry has to be the y-axis. So I could tell you right now this is neither. To prove it, well, I could multiply this out. X minus 1 times x minus 1 to make it easier. I got a 2. What is this? X squared plus 1. And I also get a minus x and a minus x plus 3. So multiply the 2 through. Combine the like terms. All right, this is this guy, but put into general form. This is vertex or standard form. Here's general form. Here it might be easier to show that if I replace x with negative x, the minus signs cancel. Minus signs cancel. Okay, and this is not the original function, right? That one had a minus, so this is not the original function. So, not even. To show it's not odd, well, this guy, factor out a minus. Okay, so when I do that, I could say, well, this is not a negative f of x, because this is not the original function, right? There's a positive 2x, and there's the negative 4, but those are different. So this is not a negative f of x, because this is not f of x. So saying that this is not that, that's the same thing as saying, again, multiply both sides by a minus. All right, either one of these statements, replacing the x with a minus does not result in having an extra minus in all the terms. So that's the same as saying the double flip is not the same as the original function. So it's not odd. Okay. So therefore, it's neither. So that's the algebra there. Now we could have done it a harder way. Just for the fun of it, we're going to do this the hard way. But again, just from the graph, this is not the same as this. And this is not the negative of that. Oops. If you want to do the algebra without multiplying it out into general form, you can, but it's kind of tricky. Let's try doing that. If I just left it like this and I replaced x with negative x, I'm going to use square brackets here. Replace x with negative x. No, I don't need square brackets. Okay, this is kind of tricky to deal with because of this stuff. All right, so how would I simplify this? Well, I can factor out a minus 1. Okay, and this would be x plus 1. Does that make sense? There's a minus, and a minus. That makes those two negative, and that's all going on inside of that. Okay, well, if I have a number times a number squared, it's the same as squaring both of those. Okay, and a minus squared cancels itself out. Now, this is in standard form. Comparing it to this in standard form, I could see that this is not f of x, because this one had a minus, this one had a plus. So you can do it this way as long as you're comfortable with doing this stuff, right? This is a number squared. When you replace x with negative x, this is a number squared. And the number that's being squared, everything has a minus, so you can rewrite it as a number squared. But this number is now a minus times this guy. And if you have a times b squared, yes, this is a squared times b squared. Okay, you can do that. Again, that's different than this. This is not a squared plus b squared. You only have two operations, addition and multiplication, right? Here you can do this. Here you cannot. Okay, so a number times a number squared, you can apply the squaring to both of those numbers. The minuses go away. And now, since we're comparing something in vertex form to vertex form, it's easy to compare each little doodad. And they are different here. All right? This is a vertex, a parabola with a vertex at 1, 3. This is a parabola with a vertex at minus 1, 3. Okay? So instead over here at 1, 3, if you flip this over the y-axis, you end up with this guy. That's what this is saying. Take this and flip it over the y-axis, you get this. And this is not the same as that. So it's not f of x, so it's not even. All right? To show it's not odd, okay, well, let's see. Since we have this guy, factor out a minus sign. If I did factored out a minus sign, I'd have to write it like this. There. Like that. Minus minus makes a plus. Minus minus makes a plus. All right, so here's our original function. This is not the original function. Okay? This guy right here. The 2 has a negative, the 3 has a negative. No, it's not the original function. So this is not the minus sign, our original function. So flipping over the left side is not the upside down right side. So it's not odd. In fact, it's even. Because this guy, this minus, we just showed that this is the same. No, I'm not going to keep going. My brain's tired. All right. It's not odd. It is even. No, it's not. Dang it. It's not odd and it's not even. Replacing x with negative x didn't give us the original function. And replacing x with negative x did not give us the negative of our function. So this guy is not this, so not even. And this guy is not this, so it's not odd. And this is the same thing as saying multiplying both sides by a minus. These are both saying the same thing, not odd. Not odd. Not even. Therefore, it's neither. Boop, 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 boop. Let's graph it and be done with this video. So the function 2x minus 1 squared plus 3. Okay. 2x minus 1 squared plus 3. You type that in. It is a parabola, vertex at 1, 3. You can tell it's not even. I flip it over the y-axis, it doesn't match. If I do the double flip, that doesn't match. Neither even nor odd, a little bit of both.